Okay. I mentioned out that 1877. Kailan ba yung ano? The analytical engine? 1837, no? In 1837, the first computer was invented by Charles W. Babbage in London. And it was programmed by Countess Ada Lovelace. Byron, no? Augusta Ada Lovelace. Okay. And several programs were written by Lovelace, no? To demonstrate that. Okay, nandito na ba si Ardinel? To demonstrate that the invention of Charles Babbage is programmable. Okay, do you follow? And what happened after the evolution, the invention of Charles W. Babbage? Nothing happened until World War II, from 1935 to 1936, 1930 to 1940s. No? Actually, the earliest invention of a computer after Charles W. Babbage was outside US. No, outside US, it's Conrad Susa. Do you follow? Okay, ito. Let's look at this. Okay, si Conrad Zuse from Germany. Okay, he finished the he started inventing the Z1. It's a digital computer, no? It's not, it's a binary computer, no? So it's not, no. In 1945 in the, okay, in the Bavarian Alps, no? He invented the Z1, Z2, and Z3. So it's otherwise known as the other first computer, because it was invented before ENIAC. ENIAC, remember, was invented in 1945. Okay, the follow. It started in 1937, but was invented in 1945. What was released in 1945. In 1935 in Germany, no, Konrad Zuse, an engineer, developed already developed a programmable computer called Z1. Okay, so no. So dito, no? What was it? Stored program? Most probably it's not stored program, no? Do you follow? It was electromagnetic machine, no? So electronic na ito, no? Electronic machine, electromagnetic machine, which processes numbers in binary, but it's not a stored program concept computer, no? So this is a replica, no, invented in 1961. The Z3, the first known digital computer, released in 1945. Unang-una siya, no? Ahead siya. Okay. He was way ahead with the computing technology in the US. Okay. So anyway, we already know the design of, primarily the design of the analytical engine. It has a mill, it has a store. Do you follow? And program execution is done such that every program in the Jacquard's loom is fetched one by one to the mill and processed into the store. Diba? So ang result nasa store. So ang program nasa mill, ang variables are in the store. You follow? Okay? So 1952 na release eh. Okay? But 1942, no? By 1942, 1952 it was released, but by 1947, no? 1945 na release din yung ENIAC, right? Let's look at the design of ENIAC. So ENIAC stands for Electronic Numerical Integrator and Computer. It was started in 1942 and was released in 1945. Okay. Which ano ito? This is Pennsylvania State University Moore School of Engineering. Do you follow? Moore School of Engineering. By the professors in physics and mathematics. No? John Vincent Atanasoff. No, this is J. Presper Eckert and John Mockley. released in 1945. If you look at the design, it has a lot of resemblance to Charles Babbage analytical engine. Okay, but it was later found out that a lot of the concepts in a previous design by John Vincent Atanasoff was adapted here. So it was possible from an IBM card reader and IBM punch cards, which was used as the output. So the store is a punch card. The ENIAC, while it has no system to store memory on its conception, later Burroughs Corporation developed a 100-word magnetic core memory for ENIAC in 1953. But by then, Presper Eckert and Moakley released a new computer called EDVAC. So instead of using mills, rather rotating gears, ENIAC used 10-digit position ring counters to store digits. So we have discussed what a ring counter is. A ring counter, it counts, it moves the value to 1 and rotate it in a clockwise or counterclockwise manner. Rotating it clockwise will divide it by 2. Counterclockwise will, rotating to the left, will multiply it by 2. It used 10-digit ring counters, okay, to store decimal digits. It had 20-digit signed accumulators. Now this accumulator was used. This was the first. This is a novelty in ENIAC because before that, the registers are called input or output registers, or according to Charles Babbage, it's ingress or egress. In ENIAC, they designed a new type of a register called an accumulator, which will be used both for input and output at the same time. That's why it's called an accumulator. So 20 10-digit side accumulators. Now for 20 rin yung 20 yung small version of the analytical engine, and 40 the actual version was 40. Pero the one assembled by Charles W. Babbage was also 20. So programming by ENIAC is done manually by setting switches. And we have that picture. So wala siyang punch card, although there's a punch card reader, but okay. This is the ENIAC, and this is the programming board. This is the programming board where the programmer set switches. Programming the ENIAC is done manually by setting switches and connecting wires in a plug board. Okay, so mayroong plug board dito. Diyan sila magkukonect if they wherever they want to go to. So the evolution goes like this. Compared to the analytical engine, the input-output in the analytical engine uses Jacquard's loom. IBM punch cards na ito sa ENIAC, okay, produced by Burroughs, for input and output. Okay. The processing unit for the analytical engine has 3 registers, 2 ingress and 1 ingress. Dalawang input, one output. For the ENIAC, there are 20 accumulators. Okay, so each accumulator is used for egress and egress at the same time. The number system is fixed point decimal. Fixed point decimal din ang ENIAC. Okay. Programming the analytical engine is sequentially done on punch cards. Dito on plug boards. The programmer was Countess Ada Lovelace. Has 1, 2, 3, 4, 5, 6. 6 programmers. It was pointed out clearly that it was a special feature, that ENIAC was programmed purely by a team of women, because this was during the war. Men were not available. The hardware was not invented physically for the analytical engine, and the hardware for ENIAC was first generation vacuum tube, vacuum tube transistors. Relay, what we mean by relay is transistor. This was invented by Charles W. Babbage in 1837. This was invented in 1946, released in 1946, updated in 1952 or 53. Moore School of Engineering. So that's the history. There's no program shown for ENIAC. And then the next after that, released in 1942, was the stored program concept. Okay. John von Neumann, 1945, Princeton College. Princeton College ito si ano? Si John von Neumann. Okay. Very popular, no? John von Neumann is very popular because he invented the stored program concept, or at least it was accredited to him. Excuse me. Although this was completed in 1952, no? John von Neumann released a report on the design of the EDVAC in 1946. Okay, this started in 1945 and was released in 1952. So 1946, nag-release siya ng design of the EDVAC, but EDVAC was developed by Eckert and Moseley. Hindi siya sinali, but it was found out that he was part of the team that initially designed the EDVAC. So there was a race to produce the first stored program concept, no? So dalawa ang naghahabulan to produce, no? Penn State University by Eckert and Moseley and Princeton College by John von Neumann. Okay, the AES machine was a binary computer like EDVAC, no? 40-bit words storing 20-bit instructions. So ito na yung mahirap ngayon dahil pag we know that computers can store instructions or data. When it stores data, it uses 40 bits. When it uses instructions, it only uses 20 bits. Okay, so main comparison between the analytical engine and the IAS. So decimal yung ano, no? Analytical engine and ENIAC is also decimal. IAS is floating point binary, hindi fixed point, no? So it can have a better calculation, no? The registers are, it has an ALU, it has a control unit, only one accumulator register, no? Na-record na ba natin dito? Yeah. One accumulator register compared to 20 of ENIAC. It has a multiplier quotient register which stores the quotient during division. General purpose registers, memory address register, data register, instruction buffer, and program counter. Okay. Input-output, Jacquard-Bloom yung sa, no? Okay. An input device is used, no, and stored into main memory. Usually this is a punch card, no? Now there's the difference, no, between the analytical engine and the IAS. In the analytical engine, programs are loaded or fetched sequentially one instruction after another via the Jacquard-Bloom, or later in the UNIVAC, no? Or even in the, mayroon bang mga IBM na hindi store program, no? Other in the UNIVAC, no? Programs are loaded from punch cards, okay, into the CPU. Okay, and data are stored separately in the memory. Now, in the stored program concept, programs are loaded by batch from storage into memory. And then it's from memory that instructions or data are both stored. So that's why it's called stored program. And instructions are fed sequentially from memory to CPU. Okay, it gives birth to the concept of fetch and execution. It was invented by John von Neumann, released in 1951, or others say 1952. No, sa Wikipedia, 1952. Okay. Any questions so far? Here's the IAS program, CPU. It has an arithmetic logic unit, ALU. It has an input-output equipment, no? Input-output device may be a punch card. It did not indicate. Okay. It has an accumulator register. It has a memory buffer register. Now, a memory buffer register is the same as an instruction register. No? When something is fetched from memory, the address is stored in the memory address register. No? When it is fetched and it was found out that what is being fetched is an instruction, the instruction goes to the instruction register. Okay. Otherwise, it stays in the memory buffer register because it's going to be used as data. Okay. Any questions? Okay. So fetch is, and then the instruction register goes to the control unit, and the control unit generates the control signals to execute the instruction. Okay. It has a main memory of how many? 1,001 kilo words of 40-bit words. No? 1024, no? So words. It's 5.1 kilobytes because one word here is 40 bits. Do you follow? 40 bits. So times 4 yon. That's all. That's 5.1. No? Okay. Here's the actual picture of the IAS. Oh. Oh, ito. Okay. Now, that's the IAS computer, the first stored program concept computer. Here's a sample program, no? Okay. On the IAS. Comment ito, no? Comment itong may semicolon. Ito yung comments, no? Do you follow? Do you follow? What do you mean by jump plus? If the result of the sub is positive, it will jump. Otherwise, it will not. It will proceed to the next instruction. Okay? Can you give this a trace and then find out what this program does? Okay. Explain in an essay. Can we do that now? Kailan ang ano nito? Deadline. Text file lang. Can you do that Wednesday, December 8, no? Simple lang naman. Okay. 10 o'clock na lang, no? Okay. Trace the program and describe what it does. Sana essay na lang. Sige lang, pass in Word or any text file, no? Okay. Do you follow? Give a trace of that program, okay, and explain what it does. Okay. Do you follow? I have the solution already, but I've hidden it in a way. No? Okay. We'll postpone this. Okay. Problems 2.1 and 2.22, that will be your next problem. Okay. Other sample programs on the IAS computer. Fourth factorial, ito no? Fahrenheit 2 meters. Fourth factorial, this. Can we analyze this? Okay. Let's erase this. Study this now, and then you study the conversion from Fahrenheit to Celsius to meters to feet. Okay. This illustrates the point now. So this time, this is the memory. This is also the memory itself, no? Do you follow? And then we have jump 5, 0 to 19, which means 0 to 19 means 5L. Do you follow? That's because the first 4 words in memory are used for data. Particularly, m of 1 is used as the first multiplier. When you compute the fourth factorial, what you do is you multiply 4 by 3 by 2 by 1. So the first multiplier is 4. Okay. And then the decrement is 1. Okay. And then we will store the result in M4. Okay. AC is the value of the accumulator. No? Load M1. So the accumulator will get M1. So M1 is 4. Remember, M1 here is 4, and then M2 is 1, M3 is 1. Okay. Load M1. So we'll have the contents will be AC receives M1. Okay. So M1 becomes 4. Do you follow? This is how we will store. No? Store M4. So M4 receives AC. So therefore, M4 will be 4. Remember that's how you program, no? In the old computers. Sub M2. So what is done? What is done by this? Anyone? AC receives AC minus M2. Diba? So sub M2. AC receives AC minus M2. So AC becomes 3. Do you follow? Okay. Store M1. M1 receives AC. Do you follow? So M1 now becomes 3. Okay. Do you follow? Mul M4. So AC receives AC times M4. Do you follow? AC is 3, M4 is 4. So AC now becomes 12. Do you follow? Store M4. M4 receives AC, which stores the partial product, which is now 12. Okay. Do you follow? Load M1. AC receives M1. So what is M1? 3. 3 now? 3. Do you follow? Sub M2. AC receives AC minus M2. Do you follow this? What is M2? It's 1. So AC now becomes 2. And then store M1. M1 receives AC. So M1 becomes 2. Okay. Our next multiplier is 2. Okay. Load M4. AC receives M4. So AC receives M4, which is 12. Mul M1. Okay. M1 is now 2. So AC receives AC times M1. So 12 times 2, this becomes 24. Okay. Store M4. M4 receives AC. This is how we trace the program, okay? I-trace niyo rin yung the support program there. So AC receives M4, so M4 now M4 receives AC becomes 24. Okay. Load M1. This means AC receives M1. What is M1? M1 is 2. 2, this is 2. Sub M2. So M2 is 1, so AC receives AC minus M2. So now AC becomes 3. We'll only subtract by 1. Okay. Store M1. M1 receives.
Ay, sir, hindi po siya 1, sir.
Asan ito? Oh, 1 day. 2 minus 1. This becomes 1, no? Thank you, no? M1 receives AC. This becomes 1. Okay. And then we load M4, no? Mali akong subtraction. Bliktad. Load M4. So we have AC receives M4. So this becomes 24. Mul M1. AC receives AC times M1. What is M1? M1 is now 1. So 24. Okay. And then this, we say store M4. So M4 receives AC. So this is 24. 24 is the fourth factorial. Do you follow? So Fahrenheit to Celsius, ganito. This is our initial Fahrenheit. What do? We multiply Fahrenheit by times 32. We subtract 32 times 5 over 9. So load M1. M1 is 132. Sub M2. M2 is 32. So 132 minus 32 is 100. Mul M3, multiply it by 5, 500. Div M4, divided by 9, 55, 56. Store M5. M5 is our final answer. 132 in Fahrenheit is 55.56 in Celsius. Okay? Meron ding meters to feet. You can study that. Okay? So that's how you trace the program. But this time, the program you are going to trace is from the IAS. We will make a comparison. No? In fact, we will make a translation. In fact, between the IAS and the PDP-1 computer. No? Okay, we'll have this later. No? Next. No? The solution is there. Okay, so the IAS computer was released in 1952. Another stored program concept computer was also released in 1952 by Eckert and Mauchly. Okay, for the U.S. Army. It was not released commercially. No? It's called EDVAC. Anong ibig sabihin ng EDVAC? Electronic Discrete Variable Automatic Computer. Okay, let's have the design. But if you look at the design, it's like IAS. Ito, the first draft report. Walang masyadong design ng EDVAC, no? But the first draft report on EDVAC was released in June 1945. 101 document. And the author is Jan van Neumann. Do you follow? Although it was registered, no, that Eckert and Mauchly designed, or rather invented the EDVAC. The first draft report on the design was authored by Jan van Neumann. So Jan van Neumann was attributed as the author of the stored program concept. Okay? Do you follow? Hindi si Eckert and Mauchly. In fact, dinimanda nga sila, no? Dinimanda sila for copying because they applied for a patent for the stored program concept and the electronic computer, no? Binary computer. But it was later rejected by the court because it was proven that the electronic compute, many of the concepts there was borrowed from the ABC computer by Vincent Atanasoff. Now, in 1952, okay, do you follow? 1953 actually ito eh. Diba? Tingnan ko nga. Or 1952, 1953 at IBM 71. Kamali ako, no? 1953 or 1952. Almost at the same time as the release of EDVAC and IAS, no? IBM also released their own program concept computer. Okay? Do you follow? So let's look at that, no? Okay, meron siyang add, meron siyang store, load is there's load and store, no? Very much the same as IAS. Do you follow? Meron siyang add, meron siyang load. Okay? And then this uses the same memory architecture, no? 24-bit word length, no? So 24 lang siya and 48. I think it's 24 and 12, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 ang kanyang 12 ang kanyang addresses. Okay? And opcodes are 1, 2, 3, 4, 5. 5-bit opcodes, so 17. I'm not sure how it but it's like the EDVAC or the IAS where there's a move left and move right. Jump left and jump right. Okay? Do you follow? So IBM 701. This was the but unlike the IAS, no, unlike the IAS and EDVAC, no, this was released commercially. Okay, EDVAC was used by the military, and IAS was used by Princeton College, no, for teaching purposes. Okay. Now, kailan itong DEC PDP-1? Second generation na ito eh. Okay. Open this. Here's the chronology of the stored program concept computers. No? Let's look at the history. Anong nangyari after the invention of the stored program concept? No? Sa 1952, na-release yung IAS. In 1951, before that, UNIVAC was released by Presper and Eckert for the Census Bureau. No? Under the name of Remington Rand. Remington Rand bought the patent for the Census Bureau, no? Famous for typewriters. No? You follow? Now, in 1952, IBM 701 produced a 36-bit data pala, no? 36-bit data and 18-bit instructions. No? The sources are conflicting. But anyway, the IBM 701 is 36-bit data and 18-bit instructions. It's like the IAS. The IAS is 40-bit and 20-bit. Sa kanya 36-bit and 18-bit. So, iniba lang niya ng konti. Operations are fixed point arithmetic, no? 5-bit opcodes, 12-bit operands. So 12 plus 5, that's 17. Kulang pa yan ng isa. Kasi 18-bit dapat eh. Meron siya reserved yung isa, no? 12 plus 5, 17. Dapat 18, no? 4 kilowords in memory. This is the only advantage because the IAS only has 1 kiloword. Diba? It uses vacuum tube diodes. Now, the IBM 701 was not released or was not sold, but it was used by it was used by Harvard. Harvard ang nagano nito. One of the customers were Harvard. They built 19, no? IBM released 19 of this and had it rented for $12,000 a month. How much is $12,000 a month? That was 1953. So you multiply it by 4. And that's a modern. So that's maybe $50,000 a month in today's time. So $50,000. That's 2.5 million in pesos in today's time. They built 19. So they profited a lot. So mga ano na ito, no? Store program concept computers. And then 1953 to 1955, 702, it was the first mainframe with lesser computational power. They built 14, but they did not release how many was sold. Okay. By 1955, this is still the first generation of computers. Vacuum tubes. O 1955, 1956 yung nag-iba na. No? They built the 704, this time from fixed point to floating point. Now uses magnetic core memory, no? Which can store up to 80 kilowords. Remember, it's only previously 4 kilowords. Now it can store 80 kilowords. They built 123 units and sold each at $2 million. No? Diba? So this is how IBM became very rich during the 1950s. There was no patent to recognize because the patent was not awarded. Hindi na award, walang patent sa store program concept. So they massively developed or produced computers and sold them very expensively. So $2 million and they built 123. So they are 123 times 2, that's 226 million, no? For IBM 704. Okay. So they released 705 with 36-bit words, 18-bit instructions, uses magnet, this time with a bigger memory, no? 1955, bigger memory, 160K. But it was withdrawn from the market. Siguro pumalpak, no? 1958, solid state transistors na, no? The 709, this is very popular, no? Single point, floating point, they did not release how many was sold. But in 1956 to 1960, transistors lang ginagamit. DEC produced, no? 1958, the PDP-1 computer. This is an 18-bit 4K memory, fixed point. The first computer with a display. They follow? The first computer with a monitor. The first ever. And uses a typewriter as a keyboard. Okay? So, let's look at the PDP-1 and look at the it's the first computer with a monitor. Ito yung DEC PDP-1. Yan ang monitor niya, bilog. Okay, because the vacuum tube was and this uses a typewriter as a keyboard, and the CPU is there at the back. Okay, bilog kasi ang vacuum tubes are round. Okay, that's the DEC PDP-1. That's 1961. No? This is a computer with the first game called the Space War. I played this, no? Kasi nandun pa ito sa mga IBM clones during the 1980s. The Space War. They sold 53 from 85,000 to 120,000 each. Much lower than IBM selling price because IBM was selling 7030, their second generation computers, for 7.7 million pesos, dollars. How many did they sell? How many were sold? It didn't show. No? By 1960, IBM released the second generation. So hindi pala ito ang 7030. Transistorized na siya, no? Transistor na ito. And they had it rented for $63,000 a month. Sold it for almost 3 million pesos, rather dollars. $3 million per unit. It was not indicated how many they sold. PDP-3 was the next, built by DEC PDP, 36 built. PDP-4, 65,000, 18-bit pa rin. This has bigger memory. And 7094, the 1962 na, so 1962 still transistors. Pagka 1963 transistors pa rin. This was the first programming language, no? IBM S360. Fortran was introduced and PDP-5 was released by DEC. 12-bit ancestor. So this is smaller. This is like almost a personal computer. Only sold for $27,000. So way cheaper. But they built 1,000 of each. No? So 27,000 times 1,000, that's still 27 million. Okay, PDP-6 was first built, the big computer by DEC. No? They built 23, mostly for MIT. Kasi sila nagpo-produce ng MIT and then IBM is producing for Harvard for $300,000 each. Okay. No? And then PDP-7, 18-bit, no, smaller than the PDP-6 for $72,000 only. Okay, sold. PDP-8, maybe the first. PDP-7, I think, is the first microcomputer rather mini computer that came into the Philippines. No? It's either UP or De La Salle had the first, no, copy. PDP-8 is a mini computer, 12-bit. This is the cheapest mini computer, sold at $18,500. PDP-9 was released, no, in 1966. So kung 1966, this is now ICs, no? ICs na ito. Pagka 1960s, na-produce na ang microcomputers. Okay? So $110,000, no? Ang PDP-8. PDP-10. PDP-12 by 1969, $27,900. This is still 1969. This is now integrated ICs. And then by the late 1970s, by the early 1970s, no? ICs na ito. Pagka 1971, this is a different era. Okay? Nauso na dito ang microcomputers. Okay? Hindi pa pala 1972, no? 1971, 72, microcomputers. And then Apple released the first personal computer at $666, no? Steve Wozniak and Steve Jobs. So the computer evolution has changed, the market has changed. The computers have reached the homes, no? Like it's an home appliance. Okay. And then Compaq, by the way, that died in 1998 because it was purchased by Compaq. So these are the popular stored program computers, DEC and IBM. Okay. Okay. Here's the DEC programming manual. I've shown you this no, last meeting, right? Napakita ko ba to last meeting? So it's much simpler, no? It's much simpler. During those times, no? For you to program the computer, you should be able to understand the architecture, which means the CPU architecture and the instruction set. Okay, so ito yung kanyang instruction set. Add, sub, para it's the same as the IAS, no? Multiply is mus. Okay? So, mul lang yung sa ano. Divide is this. Okay, and then one of the notable changes is in the load and store, no? Ang load accumulator is lock Y, 'di ba sa ano is load. Sa kanya lock Y, LAC, load accumulator. The store is DAC, DAC, deposit accumulator. Okay? Do you follow? Now, one of the distinct differences is in the jumps. Kasi wala siyang direct jump, no? Let's find out the comparison, no? Sorry. The comparison between DEC with IAS and DEC. Tayo mag-open. Ito. So ito yun. This is a sample IAS program on the left. On the right is the PDP equivalent. Okay? Do you follow? Do you follow? So you have load. Mas mahaba ito ng konti. Load M0 sa kanya lock 0. Okay? So meron pa siyang ginagamit sa address 4. Why is this like this? Because in the IAS, one word has two instructions, 4L and 4R. No? So lock 0, load M0 sa ano, IAS. Sub 2. Okay? Sub M2. Jump plus. Na, ganito 'yan, no? SAD 4. Let's look at the instruction set, no? This is a store ito no? I think store and then it goes to jump 8. It stops, no? Otherwise it goes back to okay. Okay. May mali pa dito. I'll look at the conditional jumps, no? Kasi jump plus means if the accumulator is positive. Okay? SAD, what's SAD? Let's find out. Skip ito eh. Skip. Skip if positive oh. Dapat ISP. Wala siyang direct. Ang problema sa ano, wala siya dapat direct. Okay. I'll give you another example next meeting, no? That shows a direct translation between PDP-1 and IAS. The point that I want to show here is wala na siya masyadong jump left, jump right. Okay? Because the PDP-1 is an 18-bit CPU. 18-bit both for data and instruction. Unlike in the IAS where during data they will have 40 bits and instruction they will have 20 bits. Okay. So si Conrad Zuse, no? So here's the generation of computers, no? Okay. 1940 to 1956 vacuum tube transistors. Okay, let's look at what are vacuum tube transistors. These are because computers are made of relays, no? Relays are switches actually, no? Or they are sometimes called as transistors. These are the devices that are used to make ENIAC, EDVAC, IAS, no? Ganito. Okay? Vacuum tube transistors. Now, like a switch, it can store a Boolean value on or off. Do you follow? No? So, ganyan. Ganyan yung mga vacuum tubes. Okay? Sorry, mali pa pagka I made a mistake in mali pagka-copy, no? Let me edit this first. So dapat naka-HTML. I made a mistake. I just copied this early this morning. Ito, vacuum tube. Itong Mark 1, mechanical pa ito. ENIAC was the first electronic, these are the electronic computer made of vacuum tubes. Then there's the IAS, there's EDVAC, UNIVAC, IBM 701 to 709. No? This adapted the IAS stored program concept. Okay, these are otherwise called as IAS derivatives. No? Kasi galing halos these are real almost like very similar to IAS. The main difference is 36 by 18 ito. The IAS is 40 by 20. No? 40 yung data, 18 yung 20 yung instructions. Okay. EDVAC and IAS are very similar, no? But there's no documentation on EDVAC. Only one was released. That's for the US military, no? Do you follow? Okay, solid state transistors. Have you seen this? Dito ito sa mga aircon, malalaki. Yung aircon sa bahay, merong malalaki. Ito maliliit. No, instead of the vacuum tubes, which are like this, these are the solid state transistors, three-pronged switches, no, which can be used to build flip-flops. Okay. So flip-flops. So these are the second generation of computers. No? So Texas Instruments. Okay. DEC PDP-1. Okay. Second generation of computers na ito. Sony. Okay. DEC PDP-4. Okay. And 709 to 744 of IBM are second generation of computers. These are the computers that are made of transistors instead of vacuum tubes. Na nawala yung aking ano, no? So, dito tayo. ICs. Third generation of computers, 1961 to 1972. Integrated circuits, no? Which means that the whole CPU can be in just one housing, no? So this is an IC, no? If you're not during the pandemic, we could have used an ICs in our experiments before, no? Integrated circuit, several transistors. This is already a microprocessor, no? Microprocessor na ito, no? By the way, mangita tag ibang IC. Basta IC, it's like this now, no? Ito, VLSI na. IC is that rectangular, these are now my third generation ICs. Ito na lang. Ito. Now, this is an IC. Do you follow? Where several transistors can be put, several flip-flops can be there inside, no? Okay. So these are the third generation of computers from 1965 to 1972. Integrated circuits, no? HP produced, no? DEC PDP-8. DEC PDP-8 is an IC-based computer. Okay. S30, 1970. Kasi 1973 hanggang 1973, no? 370 and 360. These are IC-based computers. Okay. Integrated circuits. The fourth generation of computers, microprocessors na ito. Okay. 1971 to 1980. Okay. In 1964, by the way, before the BASIC was already invented. No? 1970, the first computer microprocessor was produced by CTC. No? Data point 2200. No? In 1971, Hewlett Packard produced HP 98301 30A, which contains the basic programming language. Now, this is important because this is the basis of the IBM PC. Because when a computer during those days were released, it comes with a basic programming language. No? HP 901 was referred to as a personal computer. Officially, no, the first personal computer was released in 1971. And was advertised in 1968, no? Were released by HP. No? In 1972, Intel's 8008, it's a microprocessor, okay, was used by CTC in the later data point 22000 programmable terminal. So the first microcomputer was in 1973. It's Micral N from France. It was confirmed by Steve Jobs. Ito yung first nakita ni Steve Wozniak and Steve Jobs. No? The first microcomputer that they saw, it's called Micral N. In 1972, Intel released a microprocessor called 8080. Okay, and appeared in 1974 also in an extended version in 1974. Altair 88000 is a microcomputer in 1974 produced by MIPS. No? Nauna pa ito sila sa IBM. 1980s ng IBM eh. 1976 Apple. 1977 Apple II. No? 1977 okay. BASIC was introduced in the Apple computer. The first word processor is called WordStar, running on DOS, 1978. Okay. CPM DOS nito, no, running on the Apple CPM 80 MS DOS. Microsoft DOS, no, 1979. Okay. VisiCalc was first introduced by Apple. VisiCalc is the first spreadsheet. And in 1981, it was then that the IBM PC released the IBM PC. Okay, do you follow? Before that, in 1971, WordPerfect, the first graphical user with a mouse, no? Kasi in 1975 pala, no? Lisa was the first Apple computer with a mouse. Okay, may mouse na in 1979. 1984, Apple introduced the Mac computer with a graphical user interface. Actually, meron ng X Windows dito during the time yung Unix, no? Running on a DEC computer. Okay. Meron na rin. Okay. We were not the first to do. Windows was first released on DEC. No? It's called X Windows, running on top of Unix. It was later adopted by Microsoft and called it Microsoft Windows. Okay. Pero hindi sila yung original na author. No? Okay. Any questions so far? No? So that's computer evolution. No? Performance. We will solve the. I'll give you the assignment next meeting, no, on this, and I'll iron out the differences in ano. But before we close this chapter, no, we cannot close this with this is not included in the book, no, because a very important part of computer evolution is the contribution by Alan Turing. Alan Turing. British ito, Alan Turing, no. The Americans call it Alan Turing, pero sa mga British, Alan Turing. Okay? They came together, no? They met with Alan Turing met with von Neumann because he was in Princeton College, no? From Cambridge, he took up his PhD in Princeton College. Also in 1930s, no? Basta halos magka-classmates sila ni von Neumann. Okay. Here's the comment. Nag-aawayan kasi during the 1950s, no? Nag-aagawan sila von Neumann, no? Sila Presper Eckert, Mauchly and Eckert on who first invented, John Vincent Atanasoff, who invented the first computer. It was really invented already by Konrad Zuse, no? So, Alan Turing made a criticism. Ito ang sabi niya. The idea of a digital computer is an old one. Charles Babbage, a location professor of math at Cambridge. Alan Turing also studied in Cambridge. In 1829 to 1839, planned such a machine. He called it the analytical engine, but it was never completed. Although Babbage had all the essential ideas, his machine was not at that time such a very attractive prospect. No? So sabi niya, no, it runs 100 times slower than the Manchester. What is the Manchester engine? The Manchester machine was the machine used by Manchester Baby. It was called Manchester Baby during the Second World War. It was a decrypting machine used by Alan Turing. No? Manchester Baby. Okay. This was the This was the machine used by Alan Turing. Secretly, no? Because this was the Second World War, no? It was released in 1948 after the war, no? In fact, it was credited to Alan Turing to be one of his inventions, no? Who invented the Manchester Baby? It came from Poland, no? But Alan Turing reconfigured it so that it can do decryption of Enigma machines. It was when he said the Manchester machine was the analytical engine was 100 times slower than the Manchester machine. Itself, one of the slower machine of the modern machines. So, ang Manchester Baby is still slower than ENIAC, EDVAC, and IAS. The storage was to be purely mechanical using wheels and cards. Okay. The fact that the Babbage analytical engine was entirely mechanical will help us rid of ourselves of superstition. No? It is not important according to him. No? Of course, electricity usually comes in first as signaling is concerned. However, no, the feature of using electricity is doesn't to be a very superficial similarity. Superficial lang sa kanya. If you wish to find such similarity, we should took rather mathematical analogies of function of the same function. No? Ibig sabihin, there should be an analogy between the function of the electronic machine to Charles Babbage, or the Babbage invention. No? So theoretically, the main difference is the electrical part, no, according to Alan Turing. Okay. What was the invention of Alan Turing? Anyone? Alan Turing is the father of modern computer science. But what was his contribution?
Turing machine, sir.
Okay, aside from the Turing machine. So the Turing machine is now the basis for artificial intelligence, right? Diba? Did you take up automata theory? Automata theory? Diba?
Yes, sir. Meron. May automata, sir.
Automata theory. Si Alan Turing ang author ng lahat ng mga automata, no? Push down automata, all the machines, no? And he proved that the machine invented by Babbage and by von Neumann can all be invented in a Turing machine. Okay? Di ba? Yun ang sabi niya. But before that, no, during the war, his biggest contribution was decryption of Enigma machines. What's an Enigma? Another, no? That's another, what is an Enigma machine? Anyone?
Ang Enigma machine, di ba sir, yung parang gina-crypto, parang
Darmonio? Oh.
hide yung messages?
Because this was during 1937, during the war, no? When they send messages, it's just like a typewriter, and then you pick a key. Lalagyan mo ng key dito sa taas. No? Let's get better version. Meron kang iset na key dito, such that whatever you type, para siyang typewriter. Pag type mo, ang encrypt niya na, ang i-type niya sa paper, what was produced on typewritten paper, is a coded version of what you type. Do you follow? Do you get the point? Meron kang iset na switch dito sa taas. Depending on the switch, the setting of the switch, a different decryption will be produced. Encryption will be produced. Do you follow? So, in order for the recipient to read the message, he must know the key that is used to encrypt. Okay? Do you follow? Kung hindi mo alam yung key, you will not be able to read the message. This was used by the German military to send messages to their troops on the field, no? Or even send electronic messages during the telegraph. Do you get my point? Morse code. I-encrypt nila. Okay? Now, the good thing about this is, given a key, the moment you type the same, so let's say letter E. The first time you type a letter E and the second time you type a letter E, the encryption will be different. Do you get my point? So, it's very difficult to decrypt the machine, the messages, kasi hindi mag-repeat yung kanyang encryption even using the same key. So, bright kayo mga Germans. The Germans are very smart, no? So, they adopted a machine from Poland in order to now. However, Alan Turing noticed this. No, he noticed that the weakness of the Enigma machine, that it will never repeat the same key for the same letter. Do you follow? So he invented an algorithm based on that weakness to find out what was the key. Okay, what the key was really typewritten, even if you don't know the encryption key. Okay, so he invented an algorithm and revised the Manchester machine to be able to produce the key. Ang mabagal, they did it manually. No, he was able to decrypt that Enigma machine. Siya yung naka-decrypt. And since the decryption was done manually, it will take them a long time to decrypt one message. So he revised the Manchester baby to produce that part, no? To recalculate that. Yung recalculation, pinapatakbo niya doon sa Manchester baby until they are able to decrypt the messages. Do you follow? Do you get my point? So ganun yung ginawa ni Alan Turing. That's why he cannot be missed out in the evolution of computers. because of the Manchester baby. No? Actually, it was attributed to him, but it was never attributed to him formally because it was first invented in Poland. Pero gi-revise niya yun in order to be able to decrypt. And he was not even attributed as the inventor of the decryption because the team was organized by the UK government. Do you follow? And they went into a secret place and into a secret laboratory to work on the decryption. So the team who did the decryption was kept secret for a long time, except until lately, no? By the UK government. Hindi nila inano yon, hindi nila dineclare. But of course, it was accepted that the leader of the team, or in fact, no, the main contributor of the team was Alan Turing. Do you follow? Do you follow? So yun yung significance ni Alan Turing in the World War. In fact, it was because of this decryption machine that they were able to shorten the war by 2 years, because according to them, they were able to predict German intelligence when they were able to decrypt the messages. Right, guys? No? Imagine that you will be able to decrypt a message even if you don't know the encryption key. Do you follow? No? Okay. Now in 2016, kailan ba ito, no? In 2016, no? Because Alan Turing was grossly he was disregarded by history for a long time because most of his work was kept secret. Okay. In 2019, BBC made a television series. No? It's a series to determine who really is the greatest person in the 20th century. So meron silang, it's like ang tawag dyan? It's a television series, no? Okay. Several, and they later awarded Alan Turing the greatest person. Even better, no? Than Albert Einstein. Do you follow? For deciphering the Enigma machine and aiding an Allied victory in the World War II. Okay? Even surpassing Marie Curie and Albert Einstein. Okay? Awarded Alan Turing as the greatest person in the 20th century. Okay? Do you follow? Okay? Because he was mistreated. Alan Turing was mistreated by the UK government during his time. He died at a very young age. He died of suicide because he was charged with, anong tawag dyan? Indecency. Because during those times, indecency was a crime in UK. Is there an indecency crime nowadays? Bawal yung PDA, no? Public display. But indecency is no longer a crime today. Okay? Do you follow? He was convicted of indecency and he was just given a charge. He was not sent to prison because he was he played a significant role in the British military, no, as a civilian contributor of cryptanalysis. He was given a fine, and he did not accept the verdict and he committed suicide. Bomb pala ang tawag ng original machine from Poland, which they later converted into Manchester baby. Ito yun, which they use for deciphering. Okay, so that completes the this generation, and I will give you these problems next meeting. Page 22.1 and 2.2 in 58th edition and 61 on the 9th edition. Okay, for the moment you solve this. Okay, I'll assign the points later. Okay, any questions? Okay,
None, sir.
so see you next meeting now. Everyone, I'll save the recording and upload it to our regular site. Thanks everyone for coming.
Yes,
Thank you,
sir.
sir.
Bye.
Bye, sir.
Bye, sir.
Bye.
Bye, sir.